I'd like to welcome you all to our continuing seminar series on TerreWEB. And as you know, our main mission in TerreWEB is to how to work with science. Now, so far, some of you have been with us. We've had a professional journalist give us some ideas about what they're looking for. We've had academics telling us what is credible science, and we've had a number of issues related to issues of communicating science, but largely from the academic point of view and the journalistic point of view. We're very fortunate today to have a panel put together to talk to us about professionals that are involved in what is probably one of the most important issues facing the world and Canada, and that's energy and energy policy. I'll leave the introductions to our organizer. I want to thank Lois Botsil. Lois is a consultant and a graduate student. She's had 9 years of experience working with various aspects of reclamation, particularly in soils reclamation and dispersion and flocculation. She has returned after 9 years of geotechnical work. She decided to come back to the university and get a PhD. As I've mentioned in other introductions, she's an extremely bright woman, except she made one mistake, and that was she came to see me. And in spite of that, Lois, welcome, and thank you for putting this panel together for us.
Thanks, well, thank you all for coming. And I first off want to say that part of the intention for this seminar really comes from burning passions of mine and the whole intersect between the academy and what happens in the media, particularly as it relates to oil sands. As you know, what tends to happen unfit in a soundbite doesn't tend to belay or tell the whole story. And the whole intention behind this seminar is to create an extended opportunity for, one, you to get to see some of the faces behind who are the folks who are involved, or who are some of the folks who are involved with the oil sands. And you will see as I give a brief intro to some of them, and they're going to describe themselves and what they do in their own words. But you'll see that they're all people with backgrounds in science. Some of them have very strong connections or past connections with UBC, and they're all involved with different aspects of the industry. So what today's seminar is all about is letting you hear in their words how science, what role does science play? Because if you leave it to the media or what makes it into the sound clip, you would think that industry kind of does its own thing, and industry is this anomaly or this glob that's out there that kind of is only driven by one motive that isn't informed necessarily by anything. So what we're going to talk about today is a role that science plays. And it's not just the role that science plays, but what are some of the limitations associated with science. I've heard some say, well, basically scientists just need to speak louder. But what you come to find out is sometimes that doesn't play over so well in the media or in the public domain. So we're going to talk a little bit about that and have each of these individuals here speak a little bit about the role of science in their work and how they engage the oil sands. Part of what got me interested, though, in the oil sands was that unlike all of these panelists here, I'm a relative newcomer to the oil sands. In November 2008, when I actually was taking a trip up to go visit Darryl for first job I had up there, there were a couple of things. The scale of everything is a big tip-off that something's a little bit different. And there was a strange familiarity and difference that was going on. One was that it felt like every other chartered flight I'd taken to a mine site, whether it be North America or South America. The only problem was the charter was operated by Air Canada. So that's a tip-off to the scale and kind of what's going on in the industry. But the other thing was I was traveling with one of these old gray-haired types, lots of years of experience in resource development worldwide. And he commented that, most mine sites you go to, you can wrap your head around the operation in about 2 days. He figured that it would take a couple of years, and even then, you still wouldn't be able to wrap your head around what he described as the complexity of the oil sands. And that complexity is evident in almost everything you do. My whole reason for being here is this whole area of tailings management, which seems to be pretty well understood and well behaved in the rest of mining, not quite the same in the oil sands, prompting me to come here as a geotech engineer looking at chemistry. So that's just a little bit of an indication that all of a sudden we're dealing with things that may appear on the surface to be similar, but there's a lot of, the devil really is in the details, and there are a lot of details and intersections and interfaces. So I've invited some folks, some of whom I've worked with directly, and others I've come across and been recommended to, all professionals who are engaged in different aspects of industry. Brett is working for Alberta Environment. He's one of the folks who gets to review the closure plans that get put together by oil sands operators, and so is very much so engaged in that direct review process. Martin, who I have the pleasure of working with on several projects here in BC as well, is a fisheries biologist, aquatics specialist, who's also been involved with monitoring and water quality monitoring in the oil sands. Darrell Martindale, when I first met Darrell, he was responsible for environmental management at one of the oil sands operations, Shell's oil sands operations, and he's since and in the process of transitioning to Calgary, and he'll tell you a little bit more about what he does. And then Carol Jones, who I first came across when I first got into mine reclamation. C.E. Jones was the name on the front of the first report I ever looked at for reclamation and closure planning for the Huckleberry mine here in BC. So Carol's got a very long history in looking at mine impacts and figuring out how you reclaim these things. How do you get back to that point of restoration, which the public tends to be very interested in, and rightly so. And it is that point that tends to dominate the debate and dominate the discussion. Is it possible to have this development and restore some sort of environment or ecosystem that would be recognizable to not just people, but to the actual components of the ecosystem that are there prior to development? So that's kind of what we're going to talk about. So I've kind of told everybody and got them ready, and I said to them, that's as much as I'm going to do as far as introduction for them. And I'm going to let them start off by basically saying what it is that they do and how it is, the role that science plays in their particular role. So I'll start with Brett.
Sure. Anyway, thank you, Lois. It's certainly a pleasure to be here today. So, just by way of introduction, I'm a reclamation research specialist with Alberta Environment. I've worked with the government for 3 years now. Clearly, I've been around a little bit longer than that, if you look by my hairline. So, by way of example from my history, is I started out as doing a undergrad, grad, and PhD in population biology, population genetics, and rare plants in northern Saskatchewan, and just by chance in the late 90s or mid 90s, I took a consultant up to the sand dunes in northern Saskatchewan. Rare place. It's one of the few places in the boreal forest where there are endemic plants found in the boreal worldwide, and we were looking at the role that sand dune adapted plants can be used at that time for reclamation, and she, the woman I worked with had a contract at the time with oil sands development. Never remotely thought at the time I'd ever get involved in reclamation or reclamation research, and sort of went through a bit of a career change into forest ecology, and then came across this issue related to oil sands development, a challenge for reclamation. And it's an issue related to soil salinity and saline water tables, and just by way of recycling water over long periods of time, like oil sands operations do, you accumulate dissolved solids in water and then have to either have a saline water table that's going to somehow influence reclamation in the future. So we did some research looking in saline systems in the boreal forest, and there's several in Alberta and certainly throughout Saskatchewan as well in the northern part of the provinces there. And so we started to look at the role that saline soils and soil salinity plays in vegetation development, forest productivity. And I think it's interesting. I thought Clive Wellham was going to be here because he was actually in a room one day when I made this decision. Was in an argument with somebody because they were using regulator like it was a four-letter word. And I thought, you know what, those are the people that somehow represent the public and stakeholders one way or another when it's at a scientific table, at policy development or so on. And I thought, you know what, if the right job comes along someday, I'd like to take. I think I'd like to be a regulator. And a year later, his position came up. We have a new science and innovation section in Alberta Environment, and they were hiring some reclamation specialists, ecosystem and human health specialists, groundwater hydrologists, and process water engineers, tailings. And so I applied, got a job, and I've worked with the government for 4 years. And you know, from anyone from an academic research background, it's actually been a real blast. I've learned a ton of things. I would have done the research that I did for 15 years completely differently now that I've spent 4 years in government. But we get to work in a really challenging environment. There's really complex questions of reclamation for terrestrial ecosystems, reclamation for wetlands. How do we manage the scale? So Lois mentioned the scale. So I used to, a long time ago, I'll be short here, be a director with the Alberta Wilderness Association in Alberta. And so we had a few projects. We worked with the forest industry. And so, you know, we spent time standing around in 20-hectare clear cuts talking about what was the right thing to do in the boreal forest. And then the first time I went up to an oil sands operation, then I started working with the government, I realized you're sitting in something and go, I can't believe we used to talk about 20-hectare clear cuts. This challenge is just so much fundamentally different. Is like thousands of hectares are now, you know, the ground's been dug up, there's an overburden dump, there's a big hole in the ground there, we're managing tens of thousands of cubic meters of material. These challenges are way more complex than anything we ever addressed before. But you know, at the same time, while doing that, you know, you can. Some people call them failures, some people call them opportunities, but they're really complex scientific challenges that we can work on. And so, just in that respect, I'd like to suggest that if somebody was thinking of policy careers, academic careers, research careers, there's absolute need for people, but you know, at the same time, I think there's a lot of solutions are being found today, and actually the challenge is just keeping up with all the science that's being generated on a regular basis. So, a little opening comment there, and I think we'll have some good discussions here.
All right. Well, my background is in fisheries ecology, as Lois said, although I've been working in consulting for about 20 years, and I've kind of drifted a little bit more towards ecotoxicology, water quality, sediment quality. I still get to, you know, kill the odd fish, which is nice. But the work that I do has kind of gone over the last 20 years through working around the forest industry a lot, working around pulp and paper mills in particular, because I think, you know, a lot of folks in the room won't remember, but you know, 20 years ago, the climate around that industry was quite similar to what's around the, you know, oil sands now. You know, there was all sorts of people in the street saying that the CEO of Macmillan Bloedel was killing babies with milk cartons, and it was a really interesting time actually. And so I went through a lot of the development and growth of the environmental monitoring strategies around that, and over time I've kind of moved. I'm still doing some of that work, but I've kind of moved through metal mining a little bit, where I've had the chance to work with Lois and with Daryl actually a long time ago, and now I'm doing kind of a mix of things, but certainly in the oil sands. I basically have done one project in the oil sands, but it's a big one, right? I'm the water quality component coordinator for RAMP, which is the Regional Aquatics Monitoring Program, which is one of the many regional environmental monitoring programs in the oil sands. In addition, I've done work for other folks around the region. So I've worked for the Athabasca Chippewa First Nation a couple of times. I've done some work for the Athabasca Watershed Council, which is kind of like an NGO, government-associated watershed planning and advisory council. And done work for Alberta Environment Canada as well. I'll end up picking up a lot of these issues later, I think, but to maybe echo what's already been said, I think one of the really interesting challenges and the really difficult challenges of dealing with science in the oil sands generally is the scale of the developments, but also the scale of the monitoring and the scale of the science that's going on. There's so much going on by so many people in so many different areas at such a high level that it's really, really hard to keep track of, to be honest. And I think that's one of the, the key challenges moving forward, is to try to make sure that there's ways that, there's just not a whole bunch of people doing science. That's important, but there's a whole bunch of people doing science who know what all the other people are doing and how it all fits together. And that's a work in progress.
I'm Daryl Martindale. I started my career in mining. I'm a mining engineer, graduated from U of A many years ago as well. And after that, working in the industry for a bit, the coal mining industry, and participating in a couple mines that shut down. I decided that wasn't the career I wanted, so I moved into ag engineering and did my master's in irrigation and drainage, figuring I'd be able to use that, and went overseas with CUSO and did some work, on irrigation projects with agricultural cooperatives. But then came back to Canada and had the opportunity to work at Highland Valley Copper as their reclamation superintendent, and that's where I got to meet Carol and Martin on the fisheries side. So I was sort of responsible for the environmental monitoring at that time, and that was back in 1992, and it was pretty much meeting the conditions at Highland Valley. After a few years, I was really fortunate, was able to get a position as environmental superintendent at the world's largest copper and gold mine in Indonesia, the PT Freeport mine in West Papua. And it was there where I really got exposed to the importance of science in a lot of the work. And there you have 80% of the species are endemic, and I got to work with some of the best researchers in the world. Like, it was the best herpetologists from Bishop Museum in Hawaii. I worked with the botanists from Kew Gardens in England, and these people would be coming and helping us design and work on reclamation systems and that nobody had ever done before in a very harsh environment, tropical alpine, where every day of the year it could freeze. So working with all these experts and living off of their enthusiasm was pretty good experience. And during that time, I also embarked on my own area of interest, was acid rock mine drainage, and applied and was accepted at UBC to do my PhD in acid rock mine drainage, but I got a better offer at Shell's Muskeg River mine. It was starting up. It was an opportunity. I thought, great, I can get into a mine that I don't have to close. I can get into a mine that I can make a difference up front so that it's easier to close at the end. And got involved very quickly at that time, so that was in 2001, with the beginnings of a lot of the multi-stakeholder committees. So RAMP was one, another one was Wood Buffalo Environmental Association, and that's the one where I spent most of my time on the Terrestrial Environmental Effects Monitoring Group, where we were looking at the impacts of emissions on the terrestrial environment and the aquatic environment. And working with the scientists there was, again, a phenomenal experience, working with scientists from around the world doing things that have never really been done before in terms of monitoring. And we're talking monitoring with isotopes at, parts per billion. And that work is ongoing, and I just recently left after 10 years at the Muskeg River mine and have moved to Calgary to start up the Environmental Performance Improvement Group, which will be looking at how Shells can work with industry and others to reduce our impact on water, land, and air. So those are the primary objectives, and I'm just getting started on that, so hope it goes well.
Okay, Carol Jones. I used to operate a company called CE Jones & Associates, as you mentioned, for about 20 years. And we really concentrated on reclamation in British Columbia and in Western Canada. And so, yes, there are a few dusty old reports sitting out there. Actually, I did my master's here at UBC. We won't mention how long ago it was, but I did do it with Dr. Lafkovich. So we both go back a ways there. My involvement with the oil sands is a little bit different. Yes, it's in reclamation, but I work for the Fort McKay First Nation, so as a consultant. And so what I don't know if anyone here is that familiar with the mining situation in the oil sands, but Fort McKay has the enviable position of being in the center of about 6 or 7 large oil sands operations of the size that Brett was just discussing. So a lot of their traditional lands have been mined or will be mined. So they have a very large involvement in assessing what is being proposed for the area, and probably the most significant involvement in reclamation or concern about reclamation, because, as they put it, they're going to be the ones that are going to be there when the mines are done. And it will be not us closing them. Believe me, these mines are going to go on for 100 years. So in terms of communication, I was thinking, what is it that I do here to communicate? And I think I take a lot of the information that is generated by the companies and presented to the government, and I try to interpret that Western science to elders and to other community members. And I also do the flip side. I try to represent their traditional knowledge on a lot of technical Western science committees where we're working through issues about reclamation, whether it's terrestrial reclamation or aquatic reclamation. So it's very, very challenging. It's also just such a huge operation, as you mentioned, Lois, that it's actually the most interesting work that I have done in my career of approximately 30 years. So I hope you guys have lots of questions later. We're going to answer some questions I know Lois has put to us, and then I'll be pleased to answer any of yours.
Okay, so mindful of the time and the fact that I know that each of you could talk for a long time about all this stuff, we're going to focus on a couple things just to try to, and part of this is just for everyone's benefit, is to kind of prime the pump, if you will. There are some key questions that we put together about where science fits in the oil sands, and then we're going to turn it over to you all to ask your questions. Now, I will ask you and encourage you, if anything comes up in anyone's response or the question that's posed, just flag it and then be sure to raise it when we have, because we're going to have lots of time for questions. So we're not going to interrupt, but just make a note and then there'll be time and I'll be sure to get to you, okay? So one of the questions that came up, and then guys, I'm going to jump around a little bit just to try to get some stuff in, and I ask you to try to be as brief as possible just because of time. What would you guys understand to be some of the key scientific considerations that are being made right now associated with surface mining and in situ mining in the oil sands? So some of the key scientific challenges that exist. And you guys can jump in at any time. That would be question 2.
Okay.
Yeah. Go ahead.
So I mean, we touched on it a little bit. So it can be scale, temporal scale and spatial scale. I mean, at a very general level, one could sort of throw those two as two examples out. And so the temporal scale is simply a question of partly in the way these mines are managed, and the way that the development is proceeding right now is so much of the disturbance is happening up front at a time when large areas in the context of surface mining will have to be reclaimed. But the reality of these mines in terms of the way they progressively reclaim is they're large holes dug in the ground, large overburden dumps. It takes a period of time before the pits are filled in with tailing sand or some other kind of composite tailings, that there's by default a lag of reclamation in these systems. And so the conservation of reclamation material, topsoil, subsoil, conservation of biological resources that has to happen up front, we have to be very careful of how we do that, make sure that we've got some sound science that supports that, or 10, 20, 30 years down the road when it actually comes time to undertake the reclamation. If we made bad decisions 20 years ago, if we didn't expect the companies to prepare good closure plans and then execute them, we're going to have some serious challenges sometimes in the future. So that's sort of the temporal component. Then I think secondly, I'd say a challenge would be spatial scale, and I'll just present it in the context of a trade-off that one could try to consider evaluating between mining, the surface mining, which you consider as being significant ecological disturbance, versus in situ development, which is extensive, absolutely extensive. A large part of the province in Alberta would be potentially available for some kind of in situ oil sands development. So here's an example of a trade-off that one could make if you made a land use decision of where and when and how you get the oil out. Is 20% of the oil that's from a bitumen perspective, oil sand perspective, is found in 3% of the land base, and so that's the mining area. So you can get way more oil out of the ground where you mine it as opposed to where you undertake in situ development. So intensive disturbance, but more resource value in that area, or extensive disturbance over tens of thousands of square kilometers. Extensive, but not as intensive a disturbance. So it's this, there's a potential to, from a policy perspective, to try to present a trade-off of what's, if you develop the resource, where and when and how should we do it, if there's a distinction to be made between oil sands mining versus in situ.
Darryl, did you want to?
Well, I was going to provide probably a little different perspective to the question on, like to maximize the resource, there's a lot that we would like to know better about the relationship of water in the ore body. There's a lot that we don't know. The science around how the bitumen is attached to the sand to improve your recovery. How can we do that? There's a lot of work being done on the relationship on cations and anions in the water and the pH. With regards to in situ, it's not homogeneous, and a lot of people think it probably is, but these ore bodies are layered, and you got to remember they were deposited like a river. So there's cross-bedding, and there's nothing even about it. So to get good recovery, how can we achieve that when you've got a very unhomogeneous ore body? Mining, that doesn't matter because you can blend it. And for me, one of my challenges right now is how do we recycle more water? And Brett already mentioned it. We want to use less water, less fresh water, and recycle more. But as you recycle and recycle, you're going to get a buildup of the dissolved solids. And how can we pull them out of the water? We'll have to pull them out of the water if we want to recycle the water. Otherwise, we will not. So dealing with water and not creating and burdening another component, because I'm also responsible for greenhouse gases. So I don't want to clean up the water to reuse it and using pumps and high pressure through reverse osmosis processes or membranes in order to pull out the salts, because then I'm just creating another problem. So we're looking for ways to balance and to achieve those with as little energy as possible.
Martin, any comments on that one?
Go first.
Yeah, I guess I'll change the topic a little bit away from water, although I think it's very important. It has a large effect on a large component of the reclamation area. Prior to mining, approximately 50%, roughly, depending on the property you're on, of this area was some kind of an organic deposit, whether it be a fen or a bog, a few marshes. So to put back, which if we do think about the word restoration, which I tend not to talk about, but in terms of reclamation, to try and put back a similar ecosystem has never been done. I mean, it's like brand new. Everyone told me when I first went there you couldn't do it, so that's why they weren't doing it. So we've moved along, and there's now some experimental fins being developed by some of the operators. So I guess my concern is how do we try and put back this semi-aquatic, semi-terrestrial beast of a wetland, an organic wetland, with the water conditions that arise from the processing of these materials, which includes the major concern would be the salt content. So yes, there is a tie-in to the water, but it is a huge component of the reclamation that I think has to be addressed. And the second aspect around water that we haven't really talked about yet is the treatment of the water in end-pit lakes. So the idea is that after mining, there'll be a potential to backfill portions of the lakes, of the pits, and then a water cap on top of that material, which then gets called a lake. As soon as you call it a lake, then everybody wants fish in it, and it has to be this aquatic ecosystem. But it was really initially thought about as being a treatment system. So that's where we are. We have one that's just about ready to be started to be monitored in the whole oil sands. There are 28 of them planned or being built at this time, but we still have only one that we're just about to get some data from. So yeah, it's a huge challenge, and it's totally interactive with how we develop the reclamation of the area. So that's my bit on water. I'll drink some now.
All right, well, I'll bring this, I think, to a much sort of much more general set of questions, actually, and considerations. I think you can kind of break it down to 3 big issues around science. when you're looking at the the operations and performance of the industry up there, and what the kind of effects that they're having on the environment. First off is how significant are the impacts that are there. Second one is, can you return the land to a productive state, and a state that people agree is an acceptable state? And I think the third one's more of an operational one. It's not necessarily environmental science, but like, is this the best we can do? Because there's a lot of things that are done now because that's the way things have been done. There's a lot of innovation. There's a lot of effort to try to change the kind of dominant approach to how things have been done, because it is a different kind of system. They're called tailings ponds, these things, but they're not tailings ponds in like a metal mine kind of sense. They're a very different beast. They're really kind of like a water retention system, right? And that's not the only way you can do things even for those surface mines, right? But as a few people have already alluded to, the alternatives create their own sets of issues. There's a directive that the Albertan government put out a few years ago that basically requires that these tailings ponds really come down in size. And if you make these tailings ponds really small, like currently these facilities, when they're operating, they're zero discharge facilities. They're not discharging into the rivers because they have these huge freaking tailings ponds, right? And that's where they have all the water, and they're dealing with the water. The alternative is that you treat and you discharge the water, and you don't have the need for those big tailings ponds. But is that an alternative that people want? And because that brings a whole new set of questions and issues with it. So that's where best that we can. What is the best that we can? And what I think at a higher level is what do people want fundamentally in the region? What do they think is the best way to go? One last little comment on how significant are the impacts. I think one of the key issues that is continually being dealt with, and this is not an oil sands specific issue, this is a global issue, is really the establishment of meaningful thresholds for environmental quality or performance or what have you, that people agree, yeah, this is all right. We can accept this. We cannot accept this. We're kind of uncomfortable with this. This is awesome. Something like that people can actually all agree on, because there's a whole lot of different ways you can slice and dice these data, and there's a need to have basically a consistent framework to look at these things. Otherwise, everyone will always disagree about everything, and it's hard to move forward with that.
So it's kind of picking up on that, and Martin, so this is not one of the questions, but it's kind of prompted by what you just raised there. What role then does science play then in helping people figure out what is acceptable level of risk?
That's a good question. I think you weren't going to ask questions until the end. Yeah, you're running it, so you can do it. It's a good question. My view of where science fits into all these issues really is that, all science is doing science is a way of asking and answering questions in a way that is transparent, and the data that are collected and the information and knowledge that you learn from all those data and from going through them, they're there basically to provide a context for the people who want, for the broader group of decision makers to make decisions based on. I don't think that the data themselves tell anybody what to do. I think that the data provide a context to allow everyone to say, okay, well, based on what we're seeing here, we have a few different options. This looks like a really bad option based on the data. This seems like a much better option. Why don't we do that? And that's I think where these kind of issues kind of come in.
Can I just sort of touch on, I'm going to use a completely non-oil sands example, but then touch on what Carol was mentioning to bring an oil sands example. So this must have been late 80s, early 90s, right around the time that tuberculosis, brucellosis were big issues up in Wood Buffalo National Park. And so Parks Canada at the time was trying to decide how do we protect bison, wood bison, the biggest genetic population of natural bison in North America, in the context of trying to meet the goals for a Canadian park system at the time. And so there was two experts in the room. These are the two leading Canadian and international experts on ungulates and bison biology at the time. And one of them is saying, corral them, cull the herd and repopulate. And the other one is saying, just let natural selection take its course, and the bison will protect themselves and evolve in the context of the system. So two completely, so the public, stakeholders look to scientists to provide answers sometimes, and you can get two completely different, completely black and white answers from the world's leading experts. So to go back to the wetland example, because I think it's an interesting one. So in Alberta's infinite wisdom, a few years ago, they wrote in new regulatory approvals that's for a couple companies that thou shalt build a fen. And in fact, you should do it by 2012. So that's why two companies are building fens in their, or experimental fens in their reclamation areas right now, because we actually wrote it into the regulatory approvals at the time. So there's a few unintended consequences from doing that. But anyway, they're doing that, and they've got some scientists helping them out to figure it out. And so, the interesting thing is, you can take the leading international, national wetland ecologists that have absolute knowledge and a ton of publications on marshes, peatlands, bogs, and fens, and you can get one of them, if they were in this room, would say, Sandhill Fen at Syncrude is going to be an absolute failure. It's going to be saline water, it's going to come up to the surface, it's going to completely change the ecosystem, it's not going to be a fen, it's going to be a saline marsh. Failure. You can get another person who's involved in it. Both of these people are funded doing reclamation research in the oil sands, who's sort of leading the project, thinks that, no, it's going to work, we've got the hydrology figured out, and probably, by the way, half of the plants that we've picked for reclamation purposes actually will tolerate saline water tables, moderately saline water tables anyway. So it doesn't matter, we'll target a fen, but if it turns into a saline marsh, we've learned something, and that's not a failure. There are saline marshes in the boreal forest. They're still productive ecosystems, so you know what? We'll accept that as an inland use. And but if you were to sit in there, the public will listen and go, one's calling it a failure, one's calling it a success. So how do you resolve those issues when you look to internationally recognized scientists to provide you solutions?
Yeah, it's very complicated. And in fact, the two that are being built as these experimental fens are being built in very different ways, based on advice from different groups of scientists. So, I mean, it's excellent. You've got an approach with a perch system versus one that's not. I couldn't have asked for more, but yeah, it's two very opposing views on how this impossibility is going to be developed.
Okay.
Well, if I could jump in quickly again, another story. There's a metal mining EA that I worked on a few years ago that we did the fisheries component for it, and it was a really challenging thing to do, but we managed to kind of figure out how this lake worked and quantify what was going on in it. And in the CA review panel hearings, which Carol chaired actually, the proponent basically said, well, here's all this aquatic science. This is what it says, and we think that based on this science, it says that we can compensate for this lake. We can move forward with the mine. It'll be no problem. This is great. And then Mining Watch, who are if you know Mining Watch, they're not exactly very pro mining. They came up and said, well, we think this is good work too, but we think it says very clearly you should not do this development. And honestly, it was actually quite a proud moment for me, because this is the exact same data that I don't necessarily disagree with either interpretation of it, but people were applying their values to it and taking it in a different direction, and they could do that, right? And that's sort of what I mean about providing data that provide a context for decisions. Like, the data don't make the decision; the people make the decision based on the data. And it turned out that the decision that was finally made, the mine was turned down for reasons that really had very little to do with any of that data anyway. It was much larger issues that came out of it. So,
okay. So to kind of shift now to I guess a very topical consideration, that of climate change, and how is science accounted for? And so, Darryl, I'll start with you. But how does what role does science play then in the accounting for climate change and considerations about climate change and greenhouse gases and whatnot? Because that is part of your portfolio. What role does science play, not just in the planning for the mines, but in the operations, and then for everybody else in the particular work that you're doing? So whether it's the monitoring or the assessment or the regulation of the industry, where does that fit? Climate change science, where does it fit in the mix?
Well, it's an important part of mix. I mean, it's the whole energy business is about trying to meet a need. You know, there's global energy demand, and how do you meet it? It's going to be met with a bit of conventional, a bit of unconventional oil. It's going to be met with hydro, with wind, and so you're going to need all of it, and we're going to have to develop all those different sources of energy. How a mine looks at greenhouse gas or mitigates greenhouse gas, and Shell's doing this now. It's recently been in the news with the Quest project. So we're looking at carbon sequestration project, you know, from the hearings just ended last week in Edmonton, and that'll take out 1 million tons a year. So that's one way of dealing with it, is to take it and put it underground. There's you can make your mines more efficient, because I mean, if you don't need, you reduce the size of your haul roads, you can extend. There's many things you can do in a mining context, and it's all cost. So in a sense, you're trying to reduce your greenhouse gases, which you can measure, you can judge, and you can use efficiencies, because it costs you money to buy the diesel, to buy the trucks, to do all that sort of stuff. So the more you can do with less, the better. The trouble with some of the greenhouse gases in Alberta, we have a regulation, the specified gas emitters, and you set a target. So we started our target level was set at 2010 emission levels, and every year for a new mine, and every year you have to do 2% better. The trouble with that is we go, you build your plant and you start mining near your plant, and every year you have to go a little bit further, a little bit deeper, and your ore grade gets lower and lower. So if you build a plant to, you know, handle 100,000 barrels a day, you've got to get more ore because it's at a lower grade. You got to go further for it, and you got to go deeper for it. So your greenhouse gas emissions go up. And so in Alberta, we have the buying the credits and that. So for us, the strategy was look for carbon capture, and we're going to be leading that. So, but all of that science, again, you have to find the deposit, you got to look for it, you got to do the drilling. There is a lot of work, and that it doesn't exist. There's no body of knowledge that's out there. And I think if I could just add a bit more, it goes with everything, is there's a lot we don't know. And I think a lot of the answers we're looking for is science is kind of cause and effect, you know, and you can't, in a natural environment, tease that out very easily. You need 30-year studies or 40-year studies. You can look back in the oil sands to aerial photographs taken in the 50s, and McClellan Lake and some of these fens, they were dry, they were grasslands. And yet we haven't even got that variation in our climate models yet, you know, like regionally. I mean, it's never been that dry since then. So some of the elders have seen it and talk about it, but it's climate change. How do you tease out that component for what's coming? And then that's the next part for what industry has to do, is you got to plan for that. So if climate change says Alberta's going to get drier, then we're looking at retaining more water. That means building, you know, so you draw less from the river. So there's strategies that we have to come up with, and they all cost. So we're always looking for ways to, you know, do you want to retain more water? That means drawing more water, or can we reuse water we've got? So whatever way we go, it's partly to address some of those concerns as well. We don't want to be dependent or have to reduce, you know, your output because of a climate effect. You got to mitigate, and your stakeholders, your shareholders are looking at that. They're asking those questions. How can you guarantee that 10 years from now you're going to have the water you need to operate? You better come up with a plan today. So it's those drivers that are actually driving the business. So climate change in that debate goes all the way to the shareholders and the board of directors and the government and the First Nations are asking these same questions. So that's why you're going to watch the oil sands are going to try and recycle more water and deal with it, you know, so you're not dependent on the natural variations of the climate.
Carol, so part of that question, so I'm still leaving it open to everybody else, but I'm particularly curious how the Fort McKay First Nation are factoring that into their considerations. Because, you know, one of the fascinating things with dealing with First Nations is they deal on time scales that are a lot larger than even oil sands development. So how is that playing in your work with them?
It's very important. It's certainly very true. A standard terminology would be, you know, that they want this land reclaimed for their future generations, 7 generations ahead. So there's a long time scale looking forward. But there's also a lot of disbelief, primarily because they've got a generation or two that have grown up in the oil sands. Oil sands operations started in the 60s, so they've lived next to 1 or 2 of these operations for that length of time, and they're very unwilling to believe that they'll change. I can present to them new concepts from new methods of doing mining, but that's often met with a lot of disbelief. So
Brett, as a regulator, how does it fit in with what you're looking for and expecting and planning for?
So, just going to give 2 perspectives. I thought Daryl might touch on this, just from a mine management perspective, but I want to talk a little bit about adaptation as one example, because that's where we've done actually some research with UBC. So, you know, here's an example of maybe unintended consequences of new government regulations. So, in 2009, the ERCB in Alberta came up with a new tailings directive, which required a shift in the way, at least not dealing with legacy tailings, dealing with the production of tailings in the future, that companies have to take 50% of all the clays and silts that are in their oil sands or that report to the mine, and those have to be deposited somewhere on the mine site where they meet performance criteria, and it's based on geotechnical stability, trafficability. So 50% of all the clays and silts, the fines, being put in dedicated disposal areas are trafficable within 1 year, and then have a different geotechnical stability requirement after year 5. So sounds good. No more or much less reduction in growth of fluid tailings in the future, but from a technology perspective, by in particular choosing a 1-year performance criteria, the companies have, based on knowledge and technology today, have largely chosen a few choices. Syncrude with centrifugation, and Suncor with their tailings reduction operation, Shell with their atmospheric fines drying as one of a suite of technologies. Each one of these has really 2 potentially unintended consequences that hadn't necessarily been thought out at the time the regulation came out. One, a whole bunch more land is being cleared for tailings. Now it's mostly pre-strip, or depending on where it is, some of the mines, it's all pre-strip, area in front of the mine advance. So there's a bit more disturbance now than there would have been a few years ago, so that you can deposit tailings in thin lifts, dewater them. Now you've got a mud, it's not quote dry, it's not 0% water, but then you can put that in pit or manage it out of pit somewhere. So there's a bit more disturbance footprint, which may facilitate reclamation and closure in the long term, but we have to accept a higher percentage of land being disturbed today. And then secondly, is most of this material, with this technology approach, often it'll be double-handled or maybe triple-handled. So they'll put it in front of the mine advance, and somebody has to dig it up and move it somewhere else. So here, you know, just to get to the GHG climate change component, is there's the potential to now increase GHG emissions on a per barrel basis to deal with the tailings problem. So that's something we have to be aware of when you're creating government regulation, so that you actually manage all the environmental consequences when you develop new regulations. But maybe secondly, in terms of, if I can just go on for a second, climate change. So at least in the context from a reclamation perspective, we tried to assess risk if the climate changes in the future. And so like most jurisdictions in North America, I've sort of chosen a basis of anywhere up to about 5 different kinds of future scenarios. Is it warmer, drier, warmer, wetter, colder, drier, colder, wetter, and so on. And so try to evaluate with some forest ecosystem modeling, with the forest ecosystem modeling group in Forest Science here at UBC, to take our knowledge of the forest models that have been developed to help forestry in the province. They've been calibrated as much as possible to help to model future reclamation performance. And so with our knowledge of what we know now with soil moisture storage capacity, with the tree growth in relation to soil moisture and reclaimed environments, the kinds of reclamation material prescriptions that companies use, and their closure plans that say this is what we're planning to do between now and year 50 or 60 from the mine development, to apply different climates to those, to understand mortality and understand tree growth in the future, to ask the question, are the reclamation practices we're applying today, do we think with our knowledge from today, if the climate was different 10 or 20 years in the future, do we have enough knowledge to predict, they're going to perform better, or are we setting ourselves up for failure? And so that's some work that we're funding from an adaptation perspective, so that if we do see any risk associated with that, that we can start to deal with that today in terms of, do we have to think of different provenances or different reclamation prescriptions, or if not reclamation prescriptions, maybe different concept of different seed zones or provinces to help reclamation in the future. Interestingly, at least from most of the models, would suggest that, yeah, it'll be drier, but as long as you can get over that mortality phase early in regeneration, in fact, at least in the terrestrial part of the landscape, forest productivity will be higher, because there's more of a temperature effect on productivity in that part of the boreal forest than there is a moisture deficit. So it can be warmer and drier, but still, if you're thinking of productivity in the sense that forest growth models typically grow, there'll be a higher yield capability in the future. But that's not the focus of our work. We're not focused on yield capability, more thinking sustainability and productivity. Anyway.
Yeah, I might actually. I can't say much on the climate. I don't think my one undergrad course in meteorology really qualifies me to talk about climate change. But I think one thing I can say from a monitoring perspective is that these issues like climate change play out underneath all of the other things that everyone's doing, and there's an issue when you're dealing with monitoring programs that go on for decades, for example, that when you've got a shifting baseline underneath them, it creates challenges to try to make sure that what you're seeing is what you think you're seeing, because a good monitoring program basically tries to treat everything else besides what you're looking at as equal. And if that's not the case, then that makes your monitoring a lot more complex. And as an example, I can use the Thompson River. Actually, we've done a lot of monitoring work on the Thompson River annually for decades now. And there was a long-standing concern downstream of Kamloops Lake, for those of you who know the area, that nutrients that were discharged from the city of Kamloops and from the pulp mill there were really increasing the periphyton growth, the kind of slime on the rocks, and that might be having a negative effect on fish and fish habitat. Looking at the last 10 or 15 years of data, those issues seem to have kind of disappeared, and we were starting to really wonder, well, were we just imagining all this? We have data. Where's it gone? Things haven't changed that much. But one of the really interesting things about Kamloops Lake is that through the winter, like the eutrophication issue is an issue in the winter, and the reason it has been an issue in the winter is that the North and South Thompson Lakes come into Kamloops Lake really cold through the winter, and they basically slide along the top of the lake. And so when they get down to Savanaugh, the mouth of the lake, and into the lower Thompson River, it's basically the same water as you've got upstream. So all those nutrients at really low flow through the winter that have been introduced, they're just going right down to the lower Thompson River. And we've got out put out some thermistor chains in the lake over a few winters, and we found that, well, actually this is not happening anymore. The North and South Thompson River are maybe a degree or two warmer through most of the winter now. And so, the river comes into the lake and it mixes down. And so what you're seeing coming out of the lake through the winter is not this nutrient-rich, river flow that's coming straight from upstream. You're seeing basically, this massive lake and its outflow, and it's really changed the dynamic. And if you're trying to look at monitoring the effects of discharges upstream of the lake, well, the climate has changed in that situation, and the climate has basically made all of the assumptions that were in place for the monitoring program no longer valid. And that's a really interesting thing to see actually unfold in real data as we have. And I think in the oil sands context, the analogous issue maybe is upstream water flow, that for about the last 10 or 15 years, the water coming down the Athabasca from upstream of Fort McMurray has been generally lower than it was beforehand, and that has all sorts of implications for how you would design a management system based on management of flows in the river if what you've defined as normal ain't normal anymore.
Anything further on that? Okay. So basically want to then shift to this whole business of communication of science outside of the industry. So we look at monitoring, and monitoring is a good example of that. RAMP made headlines last year, and certain people on the panel had to make trips out to Ottawa and things like that. So what can you say then about how might science be better communicated outside of science and outside of the industry? Because in many cases, there's not a lot, there's certain information that's getting out and other that it's quite selective. So, and especially when you've got one group saying one thing and another scientist saying the other thing, it doesn't necessarily leave a public that knows very little again about what the industry you're left with, well, pick your pick, basically. So what would you say the role of science is in helping communication of science outside of the industry?
So here's my my last communication with the media while I was just still a research associate at the university before I joined the government. So there was an issue about using hybrid poplars, using non-native species in the boreal forest for forest management purposes. And so in Alberta, in the green zone on Crown land, you have to use, the policy is you have to, unless otherwise you have to use native species. Native species, usually from the seed zone, unless there's been a considerable research program that facilitates things like tree improvement programs and so on. So I did an interview because there was this concept, because Alpac, the big pulp mill in northeastern Alberta, has been developing a hybrid poplar program, largely on private land, right at the edge of the green zone, on the white zone, on private land. And so the reporter phones me and asks me what I think about it. And so I thought I was really good. I sent the reporter an email describing all the things. I thought I sent here's some good quotes. It's hard to get good quotes from scientists because they give large paragraphs instead of nice little sound bites. And I said, here's the series of scientific questions you have to ask before you might think it's okay to use non-native species that are related to native species on public lands from a risk management perspective. Ensure there's no gene flow, there's sterility, some other issues, and that they won't escape. And anyway, so aside from all this, the next day, lo and behold, on page 3 of the Edmonton Journal, ecologists at the university says hybrid poplars may run amok in the boreal forest, which is not at all what I said. But I was like, okay, then the next day, the ADM calls in a whole bunch of people in sustainable resource development. They waste at least 2 days dealing with this little media storm that comes out from this. And if you took 6 or 7 different bits of information that I said and put them all together in one sentence, yes, the ecologist at the University of Alberta said hybrid poplars may run amok, but that's not really what I said. It was, here's examples from zebra mussels or other places where there was unintended, things happen when species moved in places, and certainly invasive species are probably the second, if not sometimes the first most damaging thing to native ecosystems worldwide. So, the short of that is you have to be really careful sometimes when you talk to the media, and you have to try to ensure that the right message gets across. So, an example would be just today, if anyone watched the media a couple days ago, there was a press conference in Alberta because a new paper came out that looked at wetlands and wetland reclamation in the boreal forest after mining. And there's some climate change aspects to the study, some implications that spoke to the regulations or the perceived lack of regulations, and loss of wetlands, absolutely. Change of wetlands in northern Alberta because it's, as Carol suggested, wetlands we don't have the same history of reclaiming wetlands as we do upland forest. But sort of the media story focused on a couple things, which one I already touched on, the failure to do wetland reclamation, and it's largely because we haven't had a policy that directed it in the past, and we've moved away from that now. And then secondly, this focus on what we see, the focus on what's perceived to be a really interesting number, and you see it replicated time and time again. 0.15% of all disturbed land from oil sands mining has been reclaimed, and 0.15% of disturbed land has been certified as reclaimed. And so the question comes, why haven't we certified more? And so in Alberta, in forestry, we wait about 15 years before harvested land gets returned back to the Crown after it's met 2 different regeneration standards. So the province has sort of chosen, sort of as an example, about 15 years as a minimum. I'd suggest more likely 20 years after reclamation from a risk management perspective before would certify. And so it's how do you deal with this one message, one message in the media, there's been no reclamation. And another message is, well, you know what, we're not ready to certify it because in mining in Alberta, when we certify, the province takes on all reclamation liability. Not remediation, but all reclamation liability. And so we want to make damn sure when we certify that it's actually meeting what the land use objectives and the outcomes are. And so I think what we have to do from a messaging perspective is institute something that at least measures between year 0 and year 20, something that provides some kind of auditable information to the public that suggests, A, that progress is being made in that respect. I didn't really answer your question, but I just went on a little diatribe about some stories in the media recently.
That's okay. I mean, ultimately, what we're talking about is how do you retain the integrity of science in the age of the soundbite? Right? So, any other comments there?
I personally thought some of the ads that have been put out fairly recently by the oil sands companies about at least they're providing a visual. It's not so much science, but they are talking about issues and they're showing visually to Canadians what it looks like, and I think that's important. I'm thinking of the one where the engineer walks over and picks up the big clump of solidified tailings, and it's not great. But when I first started working up there, everyone had to find out where it was, what it was. I mean, we're talking 12 years ago. No one knew anything about the oil sands. So, yeah, there's some value in at least showing the big flyovers of the SAGD operations. There's some value to that. I would never call it science, but it's the beginning of informing people.
I would agree. I think there's a big component of education that has to happen because you fear what you don't know. And it is, I think it's impossible to convey a message of science with fact in 30 seconds because there's so much behind it. And I know that when I try to explain to operators, okay, I want you, our approval says you got to put 30 centimeters here on average, but because we're going to put this here, we're going to use 50 because it's on a southern exposure because there's more moisture. And he just tell me how many centimeters to put. So we'll say, oh, okay, 50 centimeters because it's got to be simple. And these are guys that deal with it all the time. I think I'm doing them a favor by saying, look, on the north side where there's not as much evapotranspiration, we'll put 30 centimeters, and on the south side we'll put 50 because we have more evaporation going on. Give them the option because it costs more per every centimeter that you put down. It costs a lot of money, especially over big areas. So they don't want that. It's just tell me what to do. So you go for the lowest common, okay, put 50 everywhere. That's what you want to do, and then your bases are covered. And I think education is, about, and that's a simple thing. That's evaporation. We're not even talking about river flows. We're not even talking about perceptions, and some of the things that people forget history again too, you hear stories, oh yeah, the river's so low, I grounded my boat the other day, and these are, guys, it's like, well, yeah, but for the last 60 years, the river was dredged every year. So you never grounded your boat because we barged up everything to Fort Chip and that, and they shut down the dredging 10 years ago. So, it makes you wonder, okay, well, these convenient facts get forgotten, and so it just takes whole education. I think history and knowledge on the ecosystem is a hard thing to communicate if you've never been there. And I think that's the other thing, is a lot of those facts are hard if you've never been there. I lived in Fort McMurray for 10 years, and you go out in the field, you go out with the elders, and you learn a lot. But if you don't have that background, that grounding, it's hard to explain that to others. So education is the first thing. I think the media has to, help in that area. Because if we do it, then you've got a vested interest. It has to be the media that tries.
Oh, I could go on forever on this one, but especially given that we were the ones who've been kind of thrown under the bus by the media, I'd say over the last couple of years. But I think to try to make sure it's kind of a positive thing here, one of the things that, I think the big thing that is the problem in trying to communicate this science to the public is, I think you've heard over and over from everyone here, it's really hard, like the stuff that we're doing is pretty complex, and anybody can figure it out if they spend long enough at it. But if you get you get the media calling up at 3 o'clock in the afternoon saying, I need something from you about this paper that came out 2 hours ago, and I need it in half an hour. What do? You can't really say, oh well, here, let me just make something up. You can't do that. You got to spend the time, and especially for a lot of the agencies that are up there, or the organizations like RAMP. RAMP, it doesn't exist legally, right? It's a group of people who do a lot of things together, and we, as the people who implement it for that group, we can't speak for RAMP, and so we'll get a call and they'll say, well, okay, we need a quote on this. What do you think? What does RAMP think in the next 10 minutes? And we'll have to say, well, I can't speak for RAMP. I have to call someone who can and get them to review it, and oh, they hate that, man. They just hate that, and so we don't. Nothing ever appears, right? And it just ends up being coming down to this sort of whoever they could squeeze a quote out of. And I understand, like a lot of media, it's an ephemeral kind of thing that's happening, right? These things appear for a couple of days and then they kind of disappear again, like they haven't existed, but they build up an impression over time. Mm-hmm. And I think that because it's such a complex, the science is so complex, and even if it wasn't that complex, and like this doesn't just apply to oil sands, this applies to really anything. I think anyone in the room who works in science, that any, basically the media is really, really bad at reporting what you know well, unless you agree with it, and then it's okay, right? But there's a real narrative bias, I think, that's introduced to the media just because they need to have something quick, they need to have something that people can kind of scan to. And so you end up with, they'll try to find someone on one side, someone on the other, get something kind of snappy and that kind of pops and shows some conflict, and they'll just move from there. And to do that, to have that kind of narrative play out, because people honestly think science is boring, but they think, people arguing that's kind of fun, like that's personalities, that's why celebrities exist, I think. But all you need is two people talking, and you've got your story, and one has to be the good guy, one has to be the bad guy. You can't have too many good guys, you can't have too many bad guys, because that just makes it way too complicated. I don't know.
Or boring.
Yeah, and I don't know, this will sound a bit silly, but I don't know if anyone remembers that movie Twister that came out in the early 90s. It had like Helen Hunt and Bill Paxton, I think, was in it. Anyway, and it's a movie about this team of rebel meteorologists who are going around and studying tornadoes so that they can help the children's crops or something, and they're basically being pursued by the evil meteorologists in the black van who are trying to corner the market in wheat futures or something, and it's just absurd. But in a lot of ways, when I read a lot of these articles in the media about science, I always think of Twister, because this is really what it's about. There's the evil black meteorologist, the white meteorologist. Make them fight, and see what happens. It does, but in the end, you don't learn anything out of it, right? And so I think really, this will sound more cynical than it is, but I think it's hopeless, frankly, to just assume that everyone's just that the media will just sort of embrace that, and that the scientists can explain into the media effectively. I think what it takes is, it's a long-term process. It's all about establishing a level of trust, having people that people do trust as being part of these processes, so that as you move forward, it becomes kind of normalized a bit. And I think you can see that happened with pulp and paper. I can think of the beginning of the environmental effects monitoring programs 20 years ago. There were meetings I'd go to where I remember a regulator called one mill's effluent a curtain of death, and they stormed out of the meeting, and we had people were screaming and yelling at each other. And now I can't even drag an environmental group to one of these meetings, because we've had 20 years, everyone's talked, everyone's kind of worked stuff out, people essentially trust each other. They don't always agree, but they know that it's not a big sham, right? That it's all people doing hard work, and it's all working out. And I think, you know, we're in the forestry building here. You know, we look at forestry in BC, and it's the same sort of thing. You know, 15 years ago, people were in the streets all over the place about it, and it's not like there's no clear cuts anymore. But when was the last time you saw people out having a massive protest about forestry? It's not that it's fixed. It's not that the system is perfect at all. But it's that there's a sense that the right people are now involved in the processes, and that even though there's problems, there's structures that are genuinely trying to address them. And I think that that's not there in the oil sands. There's just there's no level of trust, and there's no faith that the people who are doing this work are doing it in good faith. And you know, I think there's some people who can share some of the blame in that, but you know, I think the media wants that, because that makes a good read, right?
Can I just give one example?
Sure. And you give your one
It's
example.
real quick.
But we'll start with closing thoughts. You
Sure.
can start off your closing thought.
No, it just touches on.
Yeah.
So, an example, 1988, second time Brian Mulroney gets elected. He's got two main platforms: North America Free Trade Agreement, GST. You know, I will institute a GST, and we will get rid of the manufacturing sales tax. So, you know, the Conservative government gets elected with a huge majority. He institutes a GST. And which province is most objected to the GST in Canada? It's Alberta. Which province had, I think, all but one Conservative member that they elected? Alberta. And, you know, at the time, I was living there. I just moved back because I grew up in the Yukon, and so I'd moved and did some of my education in Alberta. I've now lived in Alberta longer. But you're sitting there listening to what I term redneck radio, phone in, and people complaining about this, wondering, didn't you guys just vote in Brian Mulroney and his Conservatives? Didn't we just, that was one of two major platforms of this party. Why on earth are we wasting all this time phoning in and complaining about the fact that they did one of the two things? One of the two main platforms that they were going to do, we're getting. We should shut up and accept it, right? And so, I mean, that's just one of these challenges sometimes of dealing with informed or uninformed democracy. So I'll just leave it at that without getting myself into trouble.
Okay. So are there any closing thoughts? Because we're getting ready to turn this over to the audience for questions, but are there any like burning points that you would have liked to have made at you?
Well, one I'm thinking of is I started to talk about the WBA, and you know, I often hear that, why isn't industry out there? I mean, Carol mentioned that, yeah, we're starting to get a few ads out, and I mean, I've been in part of some of them, but you know, there's two ways of going, you know, and one of them is kind of literally, you can stick your head in the sand and ignore it, you know, and I think that's the history, you know. You've had two companies been up there since '68. When was the first time you heard about the oil sands? It wasn't in '70, it wasn't in '80, bet you it wasn't in the '90s, because they were all flying under the radar, and you know, not a real big impact. Not much different than today. It is a big difference, but sorry. I mean, it's much bigger, but the issues haven't changed. I think it's just that was one strategy that seemed to work. It was provincial. It was very focused. I mean, I've worked internationally. I've been involved with media at almost every place I've been at, and it's, you know, this is another one where, guys, we got to get ahead of the game. And so the approach I've taken on the science side is, you know, at the WBA, terrestrial environmental effects, if the work isn't peer reviewed, if the work is not publishable, we're not going to pay for it. It has to have that credibility. And you're going to see in the next 2 years a whole raft of papers coming out of a 5-year piece of work that we've been doing, a team, to, you know, looking at everything from deposition on lichen sampling that we've looked at, from source characterization to source apportionment, like actually determining how much of the sulfur in that lichen 100 kilometers away comes from Syncrude, comes from Suncor, comes from Shell, and how much comes from China, and how much comes from the land all around it. You know, like, the science is incredible, and I think that's what I'm hoping is going to continue. So it's not keeping the head in the sand, but it's like, let the science work. It takes time. It takes, I think one of the things that I have found absolutely phenomenal in Fort McMurray when I first got there was the multi-stakeholders committees. Never have I seen anything like that. And the collaboration, yeah, there's been some testy times, but at the end of the day, once you work long enough with each other, there is that trust, there is that respect, you know, of their background. I mean, we all went to the same universities practically, and, you know, across Canada. And so it's once you develop that respect and trust, then you can start working together to do the science and to start trusting it and let it happen. But it takes time. You got to collect a fair bit of data over a long period of time to get to the point where you can publish. So,
Harold?
I guess I'll just close with a brief comment about the two types of science that I get involved with mostly. One, which is Western science, which is what, you know, we all practice. But then there is the traditional knowledge component, and I have one funny story for you too. And it amazed me when I was out with some elders one time on a field trip at Syncrude, and they were explaining to Syncrude how they should build a fen, and now that the scientists are building the fen, it's exactly what they told them to do, which was go out and get those pieces and move them and put them down in the right place over there on the tailings. So that was interesting. But what really amazed me was one of the elders, very shy fellow, had picked up some of the soil that he was being told was muskeg, and he sniffed it. Now, I don't know how he sniffed it. It was -20, and I wanted to get back in the truck. But he sniffed it, and he told his brother, who liked to talk, that, no, that wasn't muskeg. And he said, well, what do you mean it's not muskeg? So they got on the horn, and they talked to where this had come from on the mine, because they know where everything comes from. And in fact, it had come out of a beaver pond. So if you can tell me that they don't know their soil science, if he can tell the difference between a mineralized organic versus an organic soil at -20, I was totally impressed and quite committed to understanding more about traditional science at that time. So I think, yeah, we do need to explain Western science, but one of the audiences we have to explain it to is the people that live there. So.
I'm going to take, I want to add one bit to that too. I've started in reclamation, and we always avoided landforms that would allow beavers on the land, because we felt that if a beaver dammed the river or dammed a water stream, that it would wreck the stability of the slope or the overburden dump that you were trying to stabilize. And so we did everything we could to design around it. In these weekends where we would go out with the elders, there was one occasion where we were passing a quarry, you know, a borrow pit where gravel was taken, and there was a beaver swimming across it, and the elder said, oh, that land's healed. You know, because they always talk about healing the land, and that we'll never heal the land. But out of the blue, he used those words. That's healed. I said, well, what do you mean? What happened there? And he said, because there's a beaver there, and in our tradition, the beavers are the healers of the land. And when you think about it in the boreal landscape, it's all about damming, flooding, marsh, you know, and the succession starts with a beaver dam. And well, that just 180 degrees. So now our reclamation planning is based on how quickly can we get the beavers on the land, and so that is a 180-degree turnaround in my career on how I worked with, you know, the Fort McKay, and that was just when working with their elders. So it's to be done yet. I mean, we're still a young mine, but that's it does. You need both sciences. Yeah.
Right.
Yeah. So I guess, you know, two things. One, just to reiterate the tremendous amount of science, just fundamental science, applied science that's going on, and you know, we could go on and on about acronyms of groups that are working in oil sands related research right now. So RAMP, WBIA, we're two. There's Conrad ERG, there's SEMA, there's a variety of subgroups within SEMA. There's OSRA, an Oil Sands Research Information Network funded out of the U of A. There's COSI, there's COSIA. OSTC, these are all things that are spending anywhere between hundreds of thousands to millions of dollars worth of research. And Osley, yeah. And so it's sometimes just trying to keep up with it. But then I think more importantly, secondly, a lot of the science is, you know, it's absolutely great that it's peer reviewed. But having written peer reviewed articles myself several times, you know, and anyone who's going to do it, you realize how careful you have to be about making conclusions in peer reviewed. It's, you know, this might happen if, you know, it's based on the parameters that you set your experimentation up, whether it was describing natural systems or you did things in the greenhouse. And the fundamental thing that has to happen with all this science is it has to go through some kind of knowledge technical transfer process to make it relevant to stakeholders, relevant to industry. You know, what does this body of science mean to stakeholders? So an example would be, and this was about the last thing I did before I joined the government, we went through a knowledge tech transfer process and took all the soil science literature that existed on oil sands reclamation, on overburden dumps and tailing sand, and distilled it down into 4 volumes in terms of looking at soil characteristics, soil moisture, soil nutrient characteristics, and revegetation. Those 4 volumes then turned into a synthesis chapter, and we've yet to publish the synthesis chapter for a few reasons that I'm still not sure why, but you know, the important, actually that's the fundamental chapter, the most important thing that we did, to then say, great, now we took about 20 theses and a whole bunch of other scientific articles and said, what does this mean to industry in operational practices, or what does this mean to the public or stakeholders? And I think we have to do that with all this other knowledge and technology so that it's made in a form that's relevant to people that use it or want to understand it, so that you don't have to go and do these online searches for hundreds or thousands of articles.
So what was that, 50 centimeters?
Martin.
Yeah, I think I'll just mention a couple of things. One about the science up there, and one about the, you know, the communications of it, and how I think as a scientist you always have to kind of watch yourself, I guess. On the science side, I think that one of the real challenges up there is that there's so much going on that no one group or one person really knows what's happening up there in its entirety, and all the research that's happening, etc. I've had all sorts of experiences over the last few years of working on RAMP where I'll find something really interesting in the data, and I'll say, well, this looks like there's some change going on in Shipyard Lake here, and I wonder if I can find out anything more about that. And they'll say, well, hey, why not look at the Shipyard Lake Environmental Monitoring Program? The what? And it turns out that, you know, on the site the company's been doing this like $1 million a year program, and no one ever knew about it. And that happens all the time. And the environmental monitoring and research that goes on is this huge mosaic. And like any mosaic, there's some pieces that fit really closely and well together, and there's some pieces that don't fit well together. And I think the real challenge moving forward here with all this work is not the amount of work that's being done, or it's not the quantity, it's not the quality, it's the targeting, and it's the coordination, and it's making sure that things don't fall through the cracks, and also making sure that you don't have like 19 people doing the same thing at once, because especially the last couple years, there's been a bit of a research bonanza up there, and you can see that. And I know last year there were at least 4 groups going up and collecting sediment cores in the Delta, which is great. You know, that'll be really good data. But you know, 3 people are going to be pretty disappointed when they try to publish it. And I know from fish surveys in the Athabasca River and some of the tributaries, there's sites this last year where we know from fish collection permits that were issued that 4 different groups went in and collected fish from the same little river within a couple of months of each other. And you know, you don't want to be the 4th one, because you're not going to find too many fish left, and it's obviously going to really impact your conclusion. So having that kind of coordination to make sure that the gaps are filled, and that there's not kind of redundancy, or you're not, you know, at worst, causing environmental impacts from the amount of sampling you're doing. I think that's all really important, that stuff that needs to be sorted out as we move forward. Just on the communication side, I think that, you know, everyone, you know, for folks who do, well, I guess it's not just, it doesn't just apply to science, it applies to anything. You know, everyone is a real victim of confirmation bias, and you always got to kind of watch that you don't just go out and try to confirm your preconceived notions, because everybody does it. I do it. I like to think I don't, because I know that I will if I don't be careful. So you got to always watch out you're not doing that, and you got to try to make sure that you spread your media sources around, because I know for like when I was in my undergrad in the late 80s, there was an awful lot of discussion about the mainstream media and how normal people, like almost everyone, didn't recognize themselves in the mainstream media. It was this kind of abstract, news from above kind of thing. But with the internet now and the sort of long tail and all that, basically I don't think that anyone recognizes anything but themselves in their news sources these days. And that's a real problem, I think, because people just tend to read stuff that they agree with. Everybody does. No one wants to read stuff that kind of jars their mind, right? And so you end up with these silos of people who, and one of the things I love about being a consultant is that I can be in the same room with all sorts of people who have completely different perspectives on reality, basically, and they cannot believe how anyone else could not believe what they believe, because it's so obvious, right? And it's really fascinating to sit in the middle in these multi-stakeholder groups and other situations, and find this happening all the time. That people who are really, they're very nice, open-minded people, but they've only been talking to the same kind of person, reading the same kind of media, doing the same kind of thing, and they just completely miss each other. It's day and night for some of these folks, and I blame the internet, damn it, stupid internet. But it's a bit, that's a real important issue, I think, that needs, people need to be aware of. Don't just read the stuff that you want to read the stuff that you don't want to read. And you might think it's all stupid and disagree with it, that's totally fine, but read it anyway. Because I know for RAMP, one of my gripes is that there's a very, very clear conventional wisdom out there about what RAMP is and what it finds and what it doesn't find. And I know pretty clearly from a lot of the people who said that they've never read a RAMP report. And it is so hard to write those reports. There's such massive things that at least they should read them. And then they can criticize me all they want.
That's why
all those things are online, so read them.
That's why nobody's read them, because they're massive reports.
Tell me about it. Yeah, tell me about it.
Just take the executive summary and make sure you write the message there.
Okay, so just confirm that we have this room for an extended period of time, so if you have time you can stay home. So I want to turn over, first of all, thank you all for your contributions, and then the questions. So I hope we've got questions.
How do you strike a balance between funding for science and application of science and what the industry wants to do? I mean, if you're developing wetlands at a cost of $1 million a hectare, I know the Sentinel fan is 50 hectares and it's $50 million for its research, and they can't find that they can reduce those costs. If companies like Shell willing to, or Syncrude or Suncor willing to front that kind of money to restore the land to what it should be, as opposed to just producing more upland sites, which is easier and cheaper.
Mm-hmm. So the question I'm going to just repeat, just for purposes of recording, basically has to do with how do you, I don't think you guys heard it, but basically has to do with how do you allocate your funding. If you know that there's certain research that should be done, how does that fit with your priorities based on cost? Because at the bottom line, it has to do with cost.
Right. Well, I think in this case, it's fairly easy in that a lot of this work has never been done before. So a lot of the work that we do is piloted, and your pilot is always more expensive. Your first pilot, the 50 hectares, that's going to be your most expensive. What you learn from that, you can then apply it, and it's much, much cheaper later, because if we know that you got to put down so much of this, and this has to be impermeable and stuff like that, then as you're building your closure plan, you incorporate that into it, and so then you do it while you're moving that dirt, so you move it once. It cost $50 million because they had to excavate what they had, put down what they needed, and build it the way it was supposed to be built. So it's not going to cost $1 million per hectare 20 years from now. It'll, I don't know, I figure it'll probably be 100 to 80, or but and that's why we do it now. You go with the Cadillac, you get as much information as you can, and then you build it into your closure plans and your mine plans and all the way down.
I think what I was thinking more of is with live peat transplants, like, is that a viable option for then recreation?
Yeah, I think it is. I don't think we do it very well yet. But like anything else, it is something that we have to try to learn how to do, trying to pick up this peat when it's frozen solid and move it. It may not be the only way to do that, but I mean, it was the first one, and it happened to be one that the First Nations mentioned too. Just go pick it up and move it. Yeah, I think we'll learn so much from these fins. I think we spent a number of millions just sitting around talking about how to do it in the first place. So to be fair, there was a lot of dollars just designing it. So I think the more the more things you can try in one of these expensive ones, the better. Because once it goes through that phase, then the mining engineers are going to want to put it into a package. Okay, tell me how deep, how often do I have to build these hummocks, or what flow the water has to be, and then don't bother me because I'm going to go build 20 of them. You know, so we've got to answer all those questions in these couple of research projects.
Another question.
Back to this concept of educating the public, because it's quite oil sands in general is a very politicized development on a global scale now, and it's a very polarizing development, and it seems that there's a lot of people sort of on the against oil sands fully, and I feel like there's sort of a disconnect in their understanding of sort of the level of development that's already underway and what the feasibility of actually stopping the oil sands development entirely really is or is not. And so, however, this issue of trust is extremely important because, you know, I've seen those commercials put out on the television, and they're beautiful, and they show these, you know, great sort of fresh flowing water, and they're sampling water, and they're doing the science, and the industry is, you know, taking the proper precautions. But I feel like that's because it's an industry commercial, it's not going to be trusted by anybody whose mind is already made up. So I'm interested in knowing where you would each recommend somebody, the lay person, to go to actually educate themselves about what's really going on in sort of an objective way, in language that's not too technical. That, you know, I would argue against your comment that the internet is, you know, the problem. In fact, you know, to create a portal that could be objective and perhaps very informal, but at least can refer to the technical documents if people are interested in an engaging way, especially because the media, traditional media, is still a very important source of information for many people. But if they're not doing a good job, do you know of anything that does exist or should exist? Like, well, of course it should, but do you know of anything that does exist that you would recommend somebody to go to actually learn about issues?
So simply put, for the folks being recorded, basically, where does the public go to be educated? And that's a public that's keen and interested. This is the public, right? So, or outside of this room as well. Where does the public go to be educated?
Yeah, the internet thing was obviously a little bit facetious. I think that there are some real problems, I think, with the way science, you know, the internet has changed science. There's also really amazing things, obviously, that it's done in terms of opening up the accessibility of information to people. I think this kind of speaks to a broader issue as well, with not just oil sands, but with environmental assessments or monitoring programs for almost anything. There's this real tension, I think, in these processes between having something that is incredibly complex, like incredibly comprehensive, fully comprehensive, very, very technical, highest level of science that you can possibly get, that anyone with grade 8 education can read in an hour. You know, like these things don't actually fit together, and I think it's a much broader issue that really no one's solved. You know, like trying to get the public involved in an EA process. It's the same thing. Everyone goes, well, come on, it's like 4,000 pages of $2 words. Yeah. Well, this is volume 1.
Oh.
And how do you do it? But I'd say on the oil sands side, there's a lot of Alberta's gone kind of panel crazy over the last year or two, and like they just struck a panel 2 days ago, I think, to talk about panels, which is, it's like a meta panel. It's really bizarre.
Well, it's a commission.
Sorry, it's a commission about panels. Anyway, but I would say some of those panel reports are better than others. Some of them are pretty good. I would say the best one to go to would be actually the Royal Society report. I know it got it got a really it sort of appeared and disappeared very quickly in the media because it didn't kind of sit tidily on one side of the issue or another. Like they basically slammed everybody, which is probably appropriate, to be honest. But the great thing about the Royal Society report, aside from their perspectives, is that it has a huge section at the front end that just talks about how does the oil sands work. How do they, like, they're basically melting oil from the dirt. How do they do that? How does it work? What are the implications? Like it tries to explain up front how it works, and then it gets into some of the environmental stuff. And so it gives you a little bit more to kind of understand and contextualize that information. A lot of the other reports, if they just talk about environment, then it's really hard to understand how that actually relates to the developments or the operations. And so I'd suggest that one. And you can find that online at, I think the Royal Society has a website.
So, can I just say a couple things? So you mentioned portals. So I was involved in a project recently. We spent a couple of years coming up with a bit of a framework to develop an oil sands portal. So the Alberta government launched one in the last year. It's www.osip.alberta.ca, Oil Sands Information Portal. The intent of doing this, and so there was a lot of information on oil sands already on the internet, some of which the Alberta government did, but it all took the Alberta government perspective on it, so it had a spin if you apply it to that too. So some of us in environment started a project where we try to just get some data, and we're not necessarily, as much as possible, not going to say anything about the data, but make what we consider to be publicly accessible data and reports publicly available, because that's always the challenge. You know, anything under a regulatory approvals under a PIA, the Environmental Protection Enhancement Act, is technically public information. It's really hard to get. You know, came in reports, it's sitting in some box somewhere. If you try to get it, you probably have to go Freedom of Information request, and you may have to pay for it if it's a lot, and it takes up a lot of people's time. So a couple things have happened. One, we've moved much more towards digital submission, so we get PDFs now, and or GIS layers from companies, and we're now putting this as much as possible on the portal. So if you have questions of what are the regulatory requirements, we had the most pathetic sort of D-based kind of web interface to try to get regulatory approvals. And you know, you couldn't just type in Syncrude, you had to go %Syncrude% to do a search, and you'd come up with this long list of approvals. Now you can go to a map, go to the portal, click on oil sands projects, zoom in on the mineable oil sands, you'll see some icons, you can click on the icon, it comes up and goes, this is Syncrude. It's got a satellite image beneath it. It says, if you want to look at their PIA approval, click on this. It opens up a web page, PDF file. Here's their approval. You can read all the conditions. Shell's MRM mine has an approval that's 92 pages long that talks about how to manage air, water, land, and so on. So anyway, you can go and look at that. It's a quick access to that. It's got some access to some environmental layers to understand disturbance. You want to know how big the tailings ponds are? They're all on there. That information is there. It'll tell you how much MFT is in the ponds. So the intent was, anyway, there's a process in place to try to make information more accessible through these media without necessarily trying to interpret it, just make it available, so, and a place where you can have that discussion. So, you know, I'd suggest that, and right now it's version 1.0. There's all kinds of things we realize that we want to have on there. So you can actually find, you want EIAs, most of the EIAs you can actually click on and access all 7 volumes if that's what you're interested in. Our next stage is annual reports. Companies submit environmental reports every year. We want to get those on there. We just got updated closure plans from all the mines recently. We would like those to be on there so people can read them and understand at least what we regulate in the context of planning information companies give us and what we expect from a sort of annual reporting mechanism that we use to evaluate and audit performance when we actually go out in the field and look at things that are happening on the ground.
I understand there's a question. Yep.
Yeah, so we talked a lot about the domain sciences and also the ethical rules, how to do science. properly reported, the peer-reviewed system. We talked about communication as well, and what can go wrong and not. We haven't talked too much about the decision-making process, and I'm just wondering, is there a lack of ethical standards, how to make decisions, and what is the basis of decisions? Just on a high-level view, at the end, it comes down, where is your threshold? What is acceptable? Where we shut down the entire operation, and where we allow it? And who should make this decision? And as an example, I'd like to just take, a year ago, I think the German government chose to shut down all the nuclear power plants, I think just 2 or 3 days after this disaster in Japan. I think, is this the right way to do, to give it to the government to make those decisions, or should we let the people and the media make the decisions, or should it be a task of the basic science? So I'm still not clear where we as a society should make some rules there, or at least agree on what would be the right way to make decisions based on this story.
So that's actually one of the questions that I had posed to the panelists, because the question has to do then is the role of science in decision-making process. So I'll let you guys go for it.
Well, I kind of took a little different perspective, like how does industry make a decision? And so for myself and Shell, you know that regulations are changing. They're ever, you know, the more we learn, the more it goes. It never goes down. The regulations go up. So what I would do every year is, well, I mean, your approval is good for 10 years, but I never aim for compliance, because then you'll always be kind of missing. So you aim higher. So if we have to do this, then you do this and a little bit more. You're always doing research. That's why there's so much gray literature out there. There's so much other work that's being done, and you're checking and trying to do a better job so that you stay ahead of the regulations. So I think, and different companies have different cultures. So I'm just speaking for myself. And my goal was to always stay ahead of the regulations, and it works. It works well because on GIS, we were already doing GIS, and so when it came time to work with the government on how do we submit GIS, we worked together, say, well, this is how we're doing it, this is how it works, so great, we work on it, and so now the other companies have to catch up. So I don't want to be in that position of catching up. With regards to the birds, you heard so much about the birds at our company. 10 years ago, I had a radar system installed. We worked with a vendor to build something that was bird activated, so you get rid of habituation, you get rid of noise for Fort McKay, because we'd committed not to be noisy, and these things go off all night, all day. But if you only do it when the birds are coming in, you get rid of the habituation and it's quiet. It wasn't required, it was just to stay ahead and to do a better job. So that's how industry can make decisions based on some of the facts. The more we learn, the better we can stay ahead. How science is used is by building that knowledge, that base. And anyway, I said how industry uses it.
Well, there's of course a process before any of these operations are approved. And we were talking jokingly about panels here, and all of these are public, in that anyone can decide to go and make and ask questions, to make a presentation or ask questions of the proponents in front of the panel that will make the decision on the mine. So it's a fairly open system, but yeah, frankly, the documentation is huge, and it's very intimidating to your average person. Usually there's a few special interest groups that may make a presentation, but a few other people will. And it's unfortunate that we're almost drowning the opportunity to interact with this decision by the science that we present the table full of documents.
Yeah, I think that the governments obviously ultimately are responsible for making these decisions, and I think that they have to be. The question is really, how can you kind of tweak the decision-making process at a government level to try to make sure that all the right voices are heard, essentially. And I think scientists have to be, they play a pretty major part in that. Like these EAs are basically, you know, huge scientific investigations with then a kind of way forward tacked onto it that sort of builds from that, but isn't really the same. But you know, I think this is where a lot of these multi-stakeholder groups come in, and trying to kind of make sure that there is not just an opportunity for people to participate, but there's an expectation that they should be at the table, they should be part of all these meetings, and it should go forward. The government ultimately has the hammer, and they should use it, right? The risk, I think, and I think you know, this has happened a little bit sometimes in the oil sands, is that the government in some of these tables starts to see themselves as a stakeholder, and that obviously there's issues there. But the science, I think, is there. It's there to basically inform the debate and provide the context for the decisions. I don't think, you know, technocrats tend to make bad decisions because they're not trained in decision making, right? They're trained in, you know, alkalinity or something like that, and making a public policy decision based on alkalinity is generally frowned upon, and I think for a good reason.
So I'll just wrap up with, I think I'll try to provide a simpler example than worrying about cumulative effects management and approval of operations, and say, just if the government was going to make a regulatory decision on, say, certification for a landform, and the landform's overburdened dump, 200 hectares, and so we'd look at the approval. The approval says some things that are very specific. You know, thou shalt place so much soil over that kind of material. It might be lean oil sand, it might be saline sodic overburden, it might be tailing sand. And so, you know, you can go and dig a hole, take a yardstick, and make sure that simple things that are reclamation milestones are met. But then, you know, the approval also says thou shalt reclaim so that the landform is capable of sustaining a boreal forest ecosystem. So, how do we measure that? So the reality is we partly do it on the basis of the closure planning exercise. What does the closure plan? The closure plan identifies, based on what was there before, understanding of natural ecosystems using the same ecological land classification you use in BC, applied to the boreal forest in Alberta. So there'll be upland A, B, C, D, E ecosites, wetlands in the lower areas. So we use our knowledge of natural systems to say, well, let's go look at reference conditions to measure, are we meeting expectations? Is this a boreal forest? Is this an upland white spruce aspen forest with the right kind of understory based on knowledge of soil nutrient regimes? Is this the right kind of wetland? And so, you know, we build a database from natural systems and then measure success at year 20 as an example. But the challenge as a scientist, I think, is, you know, so we come up with a bunch of metrics, and Carol's involved in this process right now with us at the Reclamation Working Group table, looking at wetlands and uplands. We've got a whole bunch of indicators we're kind of laying on the table and to meet these criteria. But what's the threshold? You know, what's the threshold for characteristic species in an understory? So we can, you know, look at upland white spruce forests and say, you know, here's what we call characteristic species. They have the combination of abundance and frequency. They meet a prominence value, so they're the 15 characteristic species that you find. Do we take 2 standard deviations from the mean and say that's acceptable? Is that the scientific approach that we take? You know, it's really hard as a scientist to come up with a number. Do we take, you know, is it 80% of the plots have to meet a minimum criteria? Is it the landform that meets a criteria? That's where the arguments, I think we can sit down at a multi-stakeholder table and actually agree that these criteria and indicators are really good, but when it comes down to what's the number? What's the number for characteristic species? What's the number for above ground biomass as an estimate for productivity, or site index if it's a commercial forest as an example? Those, so we want to talk about soil nutrition. I think personally the best example is, what do the plants actually or for nutrient cycling actually take foliar nutrition as an example. But you know, the reality is we look at natural systems, and pretty much every stand in the boreal forest is limited from a nitrogen perspective. So we know these are going to be limited. So where do we pick the foliar nitrogen level as a limiting factor to say, you know what, you haven't provided enough nutrients when you reclaim this, you need to do something else to amend the site? That's where the arguments really start, because it's no longer a simple scientific, there's no scientific number to say 2 standard deviations from the mean is acceptable for a reclamation practice.
I think that there's a difference between industry and government in some ways, I think, is acceptance of risk. How much risk? You want 100% certainty, And that takes a long, long, long time to get. And we have to move today, and so we're willing to do it with a certain amount of risk, knowing that if you overcompensate or you do a little bit extra, chances are it should be good enough, if I was to really simplify it.
There's a question over here.
I heard earlier a certain hopelessness about the ability to deal with the media effectively. But I can think of a lot of scientists who have had extremely productive relationships with the media. And I don't think that's just because they're opponents of the oil sands, but because they believe in something. There are people who have seen a body of evidence that allow them to feel comfortable moving from the perspective of I'm an analyst to I'm an advocate. And there are members of this very faculty who have taken that position, and there's programs in this faculty. So what I want to know is if you feel hopeless, but that's not very sustainable. So what is the cause of scientists working in the oil sands? What is the story? What is the thing that will allow you to tell, give a soundbite to the media, or rally people around your idea? Because if you're fighting someone who believes that catastrophic climate change is inevitable unless we change the energy systems of the Earth, they have a damn good story. And if you're telling me that, oh, I'm just focusing on sediment level and groundwater in a very specific site, well, your story's not very exciting. And so no wonder the media is not picking up on it. And it's because they believe something. So what do you believe? What's your cause?
So as a government scientist, I don't have a cause, right? I may have some personal causes, but I mean, so that would be an example maybe as a difference of where when I was a research associate at the university, I didn't have to be as careful as a message that I might have, whereas I have to be a little more careful now what I'll say while I sit here as a government person, because I try to ensure in my role in a science and innovation section that works on government policy and funds some research and works with multi-stakeholder groups that I try to represent a government position. But so you're asking a personal question of some people, at least in their roles, that don't necessarily get to advocate their personal position. So I just like to say that sort of as a sort of opening comment. But I think more secondly, partly it's building relationships with the media too. And so I think some of the examples that you brought up are, it's important of who, some people in the media sometimes are much more willing to try to spend some time with you to understand a story, to communicate the story the way it needs to be communicated. And so, certainly I've had some. I think the example would be probably somebody gave you the inflammatory story that represents one aspect of the spectrum that they've had when they've dealt with the media.
Well, I think as usual I've been misquoted. It seems to happen all the time. I think, in the role that I'm in, I have to view myself as a servant of the process, right? And what I'm trying to do is I'm trying to make sure that I'm collecting the best data possible to satisfy all the people around the table, right? And those people represent a broad group of people. It's regulators, it's First Nations, it's industry, and in some of my other projects, it can be environmental groups, it can be all sorts of other folks. What I need to do is I need to give them good information so that they can make the decisions, because they're ultimately the people who make the decisions, right? And I think to be within those processes, I think is to give up some of your autonomy that way, right? In terms of being able to say anything you want, because it's not my role to say anything I want. My role is to understand the best I can, so that I can help other people understand the best they can, so they can advocate for a position. Like, I certainly wouldn't argue that there's no role for advocacy in science. I think that one of the things that the consultancy I work for is kind of well known for internationally is we've done an awful lot of work over the last 15 years in central Vietnam trying to make a link between dioxins in the environment and people and Agent Orange that was applied by the Americans during the war. And that's been a real battle, frankly. But we've stuck to the science. We've kept doing the science. Where things didn't it didn't kind of fit, we've reported them anyway and just moved forward. But in the end, we've managed to get the Americans, they're spending millions of dollars to remediate the Da Nang Air Base like this year. And I think that all comes from the work that we did. We didn't, we obviously had ideas about what we would find, what we hoped we would find, what we hoped we wouldn't find in some ways. But, when it came right down to it, we had a terrible time with the media in that story as well, because we didn't, we said, well, here's the data. And the media hates that, frankly. The media hates here's the data. They want, this is my passion, this is what I really believe. And, by the way, I have some data behind it. And I think a lot of scientists are bad at that, because it's not, the data, I think people feel the data should speak for itself, right? Look, all these villagers have really high levels of dioxin in their blood. They were all born after the war. It's all come from the pigs. It's amazing science, and you kind of think, well, don't people understand? This is really cool. How come they don't get excited about it themselves? Because it's not viewed that way. It's viewed at a higher level. It's viewed as it's viewed as a discussion between people about their passions, as opposed to a discussion about reality and what is reality, and moving it forward that way.
Okay, one there and one there.
Is it not your role as a scientist to translate or interpret the data in some way? You can't just say, here's a big table of data, and the rest of society who's never had any scientific training, you'd go and interpret that.
Mm-hmm. No, absolutely.
And so surely there is a role in translating, and through that you must have an opinion. It must be, because surely the data conclusion makes you have an opinion.
Well, but I agree. A table of data is just data. What you need to get to is information, which is the conclusions from that data, and hopefully some knowledge, which is the conclusions from all that information. But I'm not quite sure. Obviously we do that, but what conclusion? What position should we take on it exactly? These are one of the challenges is that these are very. There's a lot of data, and they point in some cases in certain directions, in other cases in other directions. And what we try to do is, I know from a monitoring perspective, we try to adopt the accepted approaches for trying to assess effect. So, for example, looking at invertebrates in a stream, you're looking at differences of 2 standard deviations from the mean of a reference site, or changes over time, or water quality. You're looking at guidelines. You're looking at other kinds of thresholds. Fish. You're looking for contaminants. You're looking for. There are all those things that we're looking for, and those are the criteria that we judge the data by. And then we try to bring those forward and not just say, well, alkalinity was 26. We try to say, alkalinity was 26, and that's actually really, really low for this site, and that might be a bit of a problem. We do definitely say that.
Mm-hmm.
But I think scientists should interpret scientific data in public policy debates, absolutely, because in the absence of that, who's doing the interpretation, who's providing a foundation for understanding?
Because as I understand it, a lot of politicians have the power to be able to say, they're given a briefing note or an executive summary, they make a policy decision on that, and if they don't like it, they can say, oh, well, there is some data that surely points in the other direction, can you just fiddle it a bit so it fits with the policy that I want to make? So what do you do about that?
So I have personally rejected briefing notes that have gone to the minister that I had created one way or another when the message became too simple and didn't translate what needed to be translated, and said 2 things. Either A, take my name off that, or B, change it to the one that I submitted. And though that's the only 2 choices. If this information is going to go forward, this is the way. I mean, there are opportunities to make sure that the people actually making the decision. So I'd say, if there was a passion for somebody who's a scientist in a bureaucracy, in as much as possible to make sure where you have control over knowledge, that knowledge is distilled into a package that's useful and interpretable to people that actually have the power to affect change, to make decisions, right? So, if one thought, if there was a policy, a piece of legislation, a regulation that was going through, and say, if I, in the context of your minister, failed to get it through, then, you can take it personally and say, maybe I didn't do my job in providing the right kind of information so that he or she could advance that position through cabinet and the government process. So there is a role for that to play, at least in a government process. And I'd say it's ensure that you interpret the information at a level that makes it useful for public policy decision makers too.
Now, I'm aware of the time, and I think we've got to give the room up at 3 o'clock. I think, I mean, it sounds like, oh, we've just begun, but panelists are going to be around for a little bit, and we're being flagged in the back that we have some space out in the atrium. There's also a session afterward, but we're going to move into the hallway, and they're going to be available for a little bit, so please, if people have burning questions, please be sure. But we'd like to thank them for coming, so thank you all for being here.